Hi, this is Sonia Doucette. In this video, I'll show you how to balance chemical equations. So we'll do the equation on the top first, where you have methane reacting with oxygen gas to give you carbon dioxide gas and water vapor. So the first thing to do when you're balancing chemical equations is to take account for all of the different types of elements on either side of the equation. So you can write each one down. So on the left side, you have carbon, and you have one carbon. You have hydrogen, and you can see that there are 4 hydrogens on the left-hand side, and then you have the element oxygen, and there are 2 oxygens on the left-hand side of the equation. And then you do the same thing for the right-hand side. You have carbon, hydrogen, and oxygen. Law of conservation of matter, so you have to have the same types of elements on the left-hand side in the reactants as you do on the right-hand side in the products. So accounting for how much of each we have on the right-hand side, you have 1 carbon, you have 2 hydrogens, and you have 3 oxygens. So that is not balanced because carbons are balanced, but hydrogens and oxygens are not balanced. So you have 1 more or 2 more hydrogens on the left side than on the right side, and you have 1 more oxygen on the right side than on the left side. So we need to do something about that. One thing we could obviously do to give 4 hydrogens on the right-hand side is put a 2 for a stoichiometric coefficient in front of the H2O. So now that's going to give us 4 hydrogens on the right-hand side, and that means our hydrogen values are now balanced as are our carbon values. And this is also going to change the number of oxygens on the right-hand side because there are now 4 oxygens. You have 2 and 2. So we're going to change that to 4. So just looking at that, you can see that oxygens are still not balanced because there are 4 on the right-hand side and 2 on the left-hand side. What you can easily do to get 2 on the left-hand side is put a 2 in front of the oxygen molecule reactant. So now you're going to have 4 oxygens on the left-hand side and 4 on the right-hand side. So your equation is balanced. The next one is a little bit more difficult. So here you have calcium phosphate reacting with sodium chloride to give you calcium chloride and sodium phosphate. So this is what's known as a double displacement reaction. Basically, the calcium cation is switching places with the sodium cation, and then the phosphate polyatomic anion is switching places with the chloride anion. So the compounds, they switch places and you end up with 2 different compounds. So let's do the accounting of all the elements on either side. So on the left-hand side, you have 3 calciums, you have 2 phosphorus, you have 8 oxygens, 1 sodium, and 1 chloride. And then on the right-hand side, you only have 1 calcium, you have 1 phosphorus, 4 oxygens, 3 sodiums, and 2 chlorides. So you can see here that at this point, nothing is balanced. So the first thing you can try is to balance the calciums. That's a pretty easy one. So you're just going to add a 3 in front of the calcium chloride on the reactant side. So that's going to now give you 3 calciums. So now your calciums are balanced. So next we can go, oh, we also have to add chlorides. Sorry, because you have 3 chlorides now too. So 3 times 2 is going to be 6. Chlorides still aren't balanced though, but it does change the number of chlorides you have. So now we have 6 chlorides. What can we do to balance that on the left-hand side? Well, we can put a 6 in front of the sodium chloride. So that is going to give us 6 chlorides, and that means the chlorides are now balanced on the left-hand and right-hand side. And we're also going to have to change the number of sodiums on the left-hand side to 6 because we now have 6 sodiums as well. And we still don't have a balanced equation yet though. So the next thing you can do is put a 2 in front of the sodium phosphate, because what that's going to do is that's going to give you 6 sodiums on either side of the equation. So sodium is now balanced. So what did that do to the phosphate? Well, now we have 2 phosphorus on the right-hand side of the equation, and we have 2 times 4 oxygens. So that is going to leave us with 8 oxygens. So now everything is balanced. You have 2 phosphorus atoms on either side of the equation and 8 oxygens on either side of the equation. So that's it.